Good morning, all of you. So let's continue the class. So next topic, which is very interesting, that is field of vision. Next topic, that is field of vision of fish. Field of vision of fish. So before going forward, let's draw diagram for this one. Assume that this is a fish which is inside the water, and let us suppose water is filled till here. This is inside the water. This is interface, we can say. Okay. Now you can see here, this is a water. Okay. Where is fish? Inside water, and it is watching from water only. So how much field he can view, that we are going to learn in today's class. Okay. Now you can see here, so this is what field of view for this fish. And if I am drawing one normal which is dividing this angle, it is like this. Okay. So let's denote it with the dotted line. This cone, and this cone is nothing but what? The field of vision for this fish. Let us suppose now this angle is angle C, and this angle is also angle C. And suppose fish is at depth. Fish is at depth how much? H. How much is this depth? This is H. So this is H, at which the fish is present. That is the depth. and now this is R. This cone is there, no? Its radius is suppose R. This point is, let us suppose, O point. This one is A, this one is B, and this point is, let us suppose, C or D you will, or PQR you keep. Let's keep PQR because already C for angle we have denoted. So let's name it as a PQR. Okay, but we will denote it with a PQ and R instead of ABC. Okay, so this one is P, this one is Q, and this point is R. Right? Now, fish is at depth. Fish is at depth H. Fish is at depth H. Okay. So, in this case, if you want vertex angle, number 1 point, vertex angle. Vertex angle is equal to how much? Vertex angle is how much? Can you see C plus C? How much that is? 2C. So this is vertex angle 2C. Next one. Now, in a triangle ORQ, in a triangle ORQ, see here, in a triangle ORQ, tan of C is equal to, tan of C is equal to what? This opposite by this adjacent. So this is what? OB divided by OR, which is equal to R by H, and therefore B bit, that is radius of base of cone. What is that? Radius of base of cone is equal to how much? This you see, R is equal to what? Equal to R, which is equal to H tan C. R is equal to H tan C. Next one. Now, if we will see here, this tan C is equal to what? Or first sin C if we will take from diagram, from diagram, sin C is equal to 1 by mu, and therefore tan C is equal to 1 by under root mu square minus 1. Under root mu square minus 1. 1 by under root mu square minus 1. That is what tan C. Now if I will substitute here in this, so therefore R is equal to H into 1 by under root of mu square minus 1, and therefore R is equal to H divided by under root of mu square minus 1, where mu is the refractive index of water here, okay, or the medium in which fish is present. Next one. Now can I find out area from this? See here, next page. Area of base, seaweed, area of base, which is equal to pi r square. Now this is pi, and see r value you got h by under root mu square minus 1. So if I will square that, so h divided by under root of mu square minus 1 and whole square, then this is equal to pi h square divided by mu square minus 1. This is what area of base of cone, है ना, area of base of cone. Next one, for water, note point you can write here. For water, critical angle is equal to 49, है ना. For water, critical angle is equal to 49. So therefore 2c is equal to 98. And if you will substitute all this, then you will get r is equal to 3h by root 7. So if you want to find anything from this, whatever I have given a, b, c, so you can find out for water. Okay, understood? Note down. Okay, finished. So let's move ahead. Next topic is refraction at spherical surfaces. Okay, what is that? Refraction at spherical surfaces. Refraction at spherical surfaces. So what we are doing here, we are taking two medias. Okay, one is suppose rarer medium, another is denser medium, but another medium is there that we are taking as a spherical surface. So let me draw first diagram, then you will understand. Now you can see here, this is a spherical surface. This is a spherical surface. Okay. And now assume that object is on this line. That is, you can say principal axis also. So somewhere here, this is the object. Somewhere here it is what? Object. Then because of this refraction, what happens? This light will go and fall like this on this curved surface, and after refraction it bends and comes like this from this point, right? So where image will form, here you will get image of this object. This is what image formed is. Now this distance is what from this is what u is. Okay, this distance is there, no, this is what u from this to this, and from this to this is there, that is what your phi is. What is this? Phi. And this is what u. U means what? Object distance. Phi means what? Image distance. So here it is u, here it is phi. Okay. Now let us suppose this angle is alpha. This angle is alpha. And this angle is what? Beta. Now, if I will draw a normal, then it will go through the center of curvature. You can see here. This is what its center of curvature, suppose. I am drawing with a dotted line. Okay. So let us suppose this is your center of curvature, that is C. C for center of curvature. And this angle is there, that is angle is delta. Now again I am drawing one normal from this point on this here. This is normal drawn. And this point is point M. Then again this angle will be what? I. This is what I angle is. And with respect to this is what? Angle of refraction. And from this to this is what? Your radius of curvature. This is what R is from the center of curvature. This is medium 1. Medium 1. And this one is medium 2. That is refractive index is mu 2. And for this it is refractive index is mu 1. Medium 1, refractive index mu 1. This one is medium 2, refractive index mu 2. So let's write like this: medium 1 with refractive index mu 1, medium 2 with refractive index mu 2. Okay. So here in this case, if we will, you can keep here point as here. If we will derive and we will do the geometry, what we are getting, the relation, that is mu 2 by phi minus mu 1 by u is equal to mu 2 minus mu 1 divided by r. This is what the formula, which is very useful for refraction at spherical surfaces, where u is what? Refractive index of u is what? In distance of object from this curved surface. V is image distance, r is radius of curvature, mu1 is refractive index of first medium, mu2 is refractive index of second medium. So I'm writing here where no need to derive this because nobody is going to ask you this in any exam. So you have to just solve the problem. So where mu2 is refractive index of medium 2. Next one, mu1 is what? Refractive index of medium 1. Next, r is radius of curvature. Radius of curvature. Next one is u is object distance. U is what? Object distance. And v is what? Image distance. Okay, so this formula is very, very important. Next one in this cases, that is refraction at spherical surfaces. If you want lateral magnification or transverse magnification, then what is the formula? So lateral magnification or transverse magnification, lateral or transverse magnification that is mt is equal to, what is our formula? You know, hi by h naught. In this case, you are getting mt is equal to mu1 by mu2 into phi by u. Phi by u. This is what your lateral or transverse magnification. MT denotes for transverse magnification in this case. Which case? That is refraction at curved surfaces. So whenever they are asking problem, you should use these formulas. Next, longitudinal magnification. If you want, next is longitudinal magnification in this case, then longitudinal magnification so in this case longitudinal magnification is ml, that is denoted for longitudinal magnification, is equal to m square into mu1 by mu2. M square by mu1 into mu2. Mu1 by mu. Same like if you will go for mirror or lenses, same formulas you are getting almost, and no need to derive again. So just once you got one derivation, then you can go ahead with that. Same like mirror formula, this is one refraction at curved mirrors, then transverse, then longitudinal magnification. Okay. Next one. Next one is motion of object that is along principal axis and perpendicular to the principal axis, same like mirror. So here next topic is what? Motion of object In this case, again here, how many types we are having? We are having two types. So same like mirror, one is along the principal axis, another is perpendicular to the principal axis. Let's see what are those types. So first one, I am taking it as along principal axis. And second one is perpendicular to principal axis. So if along the principal axis is there, then what is the relation? These formulas are very important. Phi is equal to mu1 by mu2 into phi by u whole square into phi naught. In case of curved surfaces, keep it in mind. And if it is perpendicular to the principal axis, then phi, that is velocity of image, is equal to mu1 by mu2 into phi by u into phi naught. There is no square here in this type of formula. Okay. So where vi and v naught is what? Velocity of image. Phi is what? Velocity of image. Velocity of image. And v naught is what? Velocity of object. Mu1 and mu2, you know. V and u is what? V is image distance. Image distance. Already I told, so no need to write, but you will confuse. That's why, because here vi and v naught is there. No, u is what? Object distance. Keep it in mind. Okay. Right. So note down this. Okay, finished. Next one. Next one, that is principal foci. Next one is what? Principal foci. So see here how you are getting. Very interesting thing. Next one, that is principal foci. So sometimes if they are asking you numericals, you should be able to solve. So first consider one curved surface. In case 1 and case 2 also both I am showing you. on one page. It is very simple. So this is case 1, suppose. This is the curved surface. And these are the rays coming from infinity. These are the light rays are coming, and after refraction, suppose they are meeting somewhere here. And this is what focus f2, and this is medium 2, that's why its refraction index is mu2. This one is medium 1, so refraction index is mu1. And this distance is what? Phi, image distance, yes or not? So here you see now u is what? Infinity. Why u is infinity? Because object is at infinity, rays are coming from infinity. Next, phi is equal to what? Phi is equal to f2, yes or not? This is nothing but focal length, so I can write it as a1 f2. So f2 is equal to v. Now let's use formula. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. Now mu1 is what? 1, but v is u is infinity. 1 by infinity is 0. So this is mu2 by v minus, this is mu1 divided by this infinity is equal to mu2 minus mu1 divided by r. This term will become 0. Which term? This term will become 0, and therefore you are getting, what is that? Mu2 by v is equal to mu2 minus mu1 divided by r. Okay. And if I will replace this phi now with f2, then mu2 by f2 is equal to mu2 minus mu1 divided by r. And therefore if I will find out this f2 value, what I am getting, just transfer this side and this side. So mu2 r divided by mu2 minus mu1. Yes, mu2 r, that is f2 value. Okay. Now second, case 2. Now again this is your case 1, that is from rarer to denser medium, you can say, or air to glass, we can say, or even we can say that it is a parallel rays. First case is what? Parallel rays. Okay. So next one, see the diagram. I'm using color. Another one. So second one. This is the first case when object is at infinity. Okay. This is second case when object is at f1. So again I am drawing diagram. So you can see here, this is a diagram for this. And now assume that these rays are coming like this now from this point. Then after this, how they are going? Parallel. Or not? They are going parallel. So this is the object here, and this medium is again mu2. This one is mu1. And now this is your u1, but u1 is nothing but what here? f1. And object is at object distance is f1, image distance is infinity, because we don't know where image is getting found. So for this, see now, here u means object distance is equal to f1, and v is image distance, which is infinity. So let's use formula again. So what is our formula? Mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. Now v is infinity, so this is 0, minus this is mu1 divided by this is u is equal to f1 is equal to mu2 minus mu1 divided by r. So again, if we will find out f1, then we'll get f1 is equal to mu1 into r divided by mu2 minus mu1. Mu2 minus mu1. This is minus sign. Okay. Now if suppose now this is your equation number 1 and this is your equation number 2, then from 1 and 2, what you are getting? From 1 and 2, this f1 by f2, if we will do, f1 by f2 is equal to what you will get? Mu1 by mu2. Mu1 by mu2. That is minus sign is not necessary here, right? So we'll get ratio like this, mu1 by mu2. Okay. And one more formula you keep it in mind, note point for this. Now, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. And if we will substitute this phi value and this r value here, then I am multiplying now with r by mu2 minus mu1, multiplying on both sides, multiplying on both sides by r by mu2 minus mu1. So multiply karo, see here what you will get, mu2 into r divided by phi into mu2 minus mu1 minus mu1 into r divided by mu2 minus mu1. This is equal to mu2 minus mu1 divided by r into r divided by mu2 minus mu1. Okay, so this will get cancelled, and if we will substitute this value, this is what f2 value. So here it is f2 by phi plus f1 by u, because here minus already is there. Minus means minus f1, you are getting minus minus plus, so this is equal to 1. This is what the formula in case of principal foci. Got it? So note down this, because our f1 formula is what you can see here. F1 is equal to minus mu r by mu2 minus mu1. Okay, f1 is equal to minus na, so direct you are getting f1 here. You can write here f1 is equal to minus mu1 r by mu2 minus mu1. So at the place of that everything I have substituted this my f1, and therefore I got this formula. So whenever you are solving problem and you want to find f1 or f2, you can use this formula. Okay, let's stop here. Please revise carefully this ray optics, right? So let's stop here for today. Bye.